Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the topic tuned amplifiers in analog electronic circuits. So we all know that the amplifier is a circuit which is used to boost the signal strength. A weak signal is converted into a strong signal with the help of amplifier circuit. So here in case of tuned amplifier, we will have a load circuit which is a tank circuit. So the load here will be a tank circuit such that it can be tuned to pass or amplify the selection of the desired frequency or a narrow band of frequencies. So this is known as tuned circuit amplifier. So this will select and amplify a single frequency from a mixture of frequencies in any frequency range. So tuned amplifier will employ the tuned circuit, which is the tank circuit, and it uses the phenomena of resonance. So a tank circuit which is capable of selecting a particular or relative narrow band of frequencies is called as the tuned amplifier. So here the frequency generated, the center of this frequency band is called as resonant frequency of the tuned circuit. So here, so this is called as the tank circuit. The inductor connected in parallel with the capacitor forms the tank circuit. So we have the common emitter amplifier circuit here. The input signal is given through the base and the output is obtained from the collector here, where we have the tuned circuit, that is tank circuit, being connected at the collector terminal, and the voltage divider bias. So the voltage here is getting divided between two series resistance R1 and R2, and we have the emitter resistance for providing the temperature stability for this circuit. And the tuned circuit here is given, that is the L connected in parallel with the C, inductor and capacitor. So when at particular frequency, if the inductive reactance become equal to the capacitive reactance, then the circuit will behave purely a resistive circuit. This phenomena we call it as the resonance, and the corresponding frequency is called as resonant frequency. And the classification of tuned amplifiers are, generally we classify it as small signal and large signal. So small signal tuned amplifiers are to amplify low RF signals, and here the power output is low, and normally it is operated in class A. So we have three categories of small signal amplifiers under class A, that is single tuned, double tuned and staggered tuned. And in large signal, these amplifiers are to amplify the large RF signals. So we also call this as power amplifiers, and the power output is more here, and it is operated in class B, class C and class AB modes. So these are the classifications of tuned amplifier. So first let us discuss in detail about single tuned amplifier. So a simple transistor amplifier circuit will have the tuned circuit, that is the capacitor and the inductor connected in parallel will form the tuned circuit in its collector load. So the load will have tuned circuit, we have discussed, right? So in that the load is connected in the collector terminal, and our tank circuit consists of this capacitor and inductor. So the values of these capacitance and inductance of the tuned circuit, they are selected such that the resonant frequency is equal to the frequency which is to be amplified. And now the high frequency signal to be amplified is applied at the input. So at this stage, the tuned circuit will offer higher impedance to the signal. So this helps to offer high output across the tuned circuit. As high frequency, this high impedance is offered only for the tuned frequency. All other frequency which is having the lower impedance are rejected here in the tuned circuit. Hence, this tuned amplifier will select the and it will amplify the desired set of frequency signal. This is the circuit of a single tuned amplifier. So we have only a single set of tuned circuit at the collector load. So the frequency response for the single tuned amplifier is given here. We can see that the bandwidth here is narrow. So we call tuned amplifiers as narrow band amplifiers, and the frequency is given by 1 by 2 pi root LC. And the disadvantages of this kind of amplifiers are this is required to be highly selective. So, but high selectivity requires means the Q factor here will be high. But when the Q factor is high, it means that it will reduce the bandwidth since the bandwidth is inversely proportional to Q factor. So it means that the tuned amplifier with the reduced bandwidth will not be able to amplify equally the complete band of signals, and the result is here poor. So the next is a double tuned amplifier. So here we will have two sets of tuned circuits at the load. Here at the collector load we can find that you have L1C1 and L2C2. So here this is mutual induction occurs here between L1 and L2. So we have two sets, hence we call this as double tuned amplifier. So two tuned circuits, that is L1C1 and L2C2 in the collector section of the amplifier. The signal at the output of the tuned circuit L1C1 is coupled to the other tuned circuit through mutual coupling method, and the other parts are similar to that of the single tune amplifier. So as we have discussed there, the high frequency signal to be amplified is given to the input of the amplifier, and the tuning circuit is tuned to the input signal frequency. So at this condition, we have discussed already, the tuned circuit offers high reactance to the signal frequency. So the large output which appears at the output of this tuned circuit L1C1 is coupled to the other tuned circuit through mutual induction. So these double tuned circuits are used for coupling various radio and television receivers. So the applications of tuned amplifiers are they are used for in the circuits of video signal amplification, for wireless long distance communications, and at the receiver stage these are used as radio frequency amplifiers. And today's assessment is what is the bandwidth of the resonance circuit with a frequency of 28 megahertz and quality factor of 80. So we know that bandwidth is resonant frequency divided by quality factor. Substituting the values, we obtain the bandwidth. The next one is calculate the reactance of 100 picofarad capacitor at an operating frequency of 2 megahertz. So we all know that the capacitive reactance is Xc is equal to 1 by 2 pi Fc. So substituting the given values will give us the value for the capacitive reactance. Thank you.